welcome to class. So please put in the chat the audio from 1 to 10 before we start the recording. Okay, thank you. I see Genesis, Miguel, Stephanie, Juan, and Justin participating in the chat. Thank you. Okay, let's go ahead and start the recording.
Recording in progress.
This recording will cover the rest of section 3.5. So this is section 3.5 continued. We're going to take a look at the last two problems in this section, which we'll put a double star for us to review and practice. Sorry. Okay. So in section 3.5, we learned about the double angle. Sorry. Excuse me. We learned about the double angle and the half angle identities. Thus, if we're given a trig function evaluated at the double angle or half angle, we are able to find the trig functions evaluated at the original angle. So given cosine of 2 theta, we can find any trig function at theta. For these problems, pay attention to the input. You're given cosine at 2 theta. You want to find sine and tangent at theta. And then always circle the quadrant and make note of that. Okay. So when you're given the info about one trig function and you want to find the rest, we have two different strategies. We can use the Pythagorean identities or the triangle method. So I'll remind us to the side here, we have two options. We can use Pythagorean identities. With the Pythagorean identities given the exact value of one trig function, we can find the exact value of all 6 trig functions evaluated at that angle. Or we could use the triangle method. Given the exact value of one trig function, we can fill in our right triangle. And with the right triangle, we can find the exact value of all 6 trig functions. So two different methods, Pythagorean identities or triangle method. Okay. Okay. So since a majority of students said that they prefer the triangle method, we are going to use the triangle method in these two problems. However, if you prefer using Pythagorean identities, that works as well. Okay, but to start with, we need to be aware of what's given. We're given cosine 2 theta, and we want to find sine of theta, tangent of theta. So make note that we're given the trig function at 2 theta, and we want to find two of the trig functions at theta. Okay, so we need to use the identity. For double angle identities for cosine, we have 3 different options. Let me bring us back here. Remember, we want to find sine of theta and tangent of theta. Okay, so we're going to start with Jacob. Jacob, these are our double angle identities that we want to have on our reference guide. Which double angle identity for cosine should we use if our goal is to find sine of theta, tangent of theta? Jacob, check your mic.
Sorry. Would it be vanilla, the first one?
Okay, if we use vanilla, vanilla has both sine and cosine in it, so we have 2 unknowns. we would only be able to solve for two unknowns if we had two equations. We want to choose one where there's only one unknown that we could solve for. And remember, we want to find sine and tangent. So which one would be best here?
Then the second one.
The second one will help us solve for cosine. That's chocolate. How about the third one? Oh, okay, so let's try strawberry because strawberry gives us cosine of 2x in terms of sine, and that's what we want. We want to find sine. So let's try strawberry. Okay. Okay, students. So the identity we choose is dependent on what they ask for. Here we want to find sine of theta. So we're going to pick the identity that's just in terms of sine. If we wanted to find cosine of theta, we'd pick the identity just in terms of cosine. Okay. So we're going to use strawberry, which tells us cosine of 2 theta is 1 minus 2 sine squared theta. So we replace cosine of 2 theta with 1 minus 2 sine squared theta. So this is strawberry. Okay, so now we can solve for sine of theta. Okay, so let's get a common denominator. We could rewrite 1 as 5 over 5. We want to isolate sine of theta. So let's subtract 5 over 5 from both sides. We get negative 2 sine squared theta is equal to, this is going to be negative 2 over 5. Okay. To isolate sine squared, let's multiply both sides by negative 1/2. Sine squared theta is now equal to, we have, let's see, 2 divided by 2 is 1. Negative times negative is positive, so this is 1/5. Okay. Okay, so sine by itself is going to be plus or minus 1 over root 5. Remember, we always need to rationalize the denominator when we have square roots in the denominator. And then from here to determine if your trig function is positive or negative, we look at the quadrant. So off to the side, we'll put in, they give us that 2 theta is between 0 and 90 degrees. So let's divide everything by 2. Theta is going to be between 0 and 45 degrees. Okay, so that means that theta is in quadrant 1, where x and y are both positive. We have to be careful here because they give us the quadrant for 2 theta. We have to determine the quadrant for theta. So here theta is in quadrant 1, which means that all 6 trig functions are positive. So sine of theta is positive root 5 over 5. Okay. So that's applying our double angle identities. We want to find sine of theta and tangent of theta. Okay. Okay, so if we were using Pythagorean identities, given sine, we can find cosine. Given cosine, we can find secant. Given secant, we can find tangent. So we could apply different Pythagorean identities to go from one trig function to another. However, sometimes the triangle method may be more direct because once you've drawn the triangle, right triangle, you can get any trig function evaluated at theta. Okay, so remember that sine is the ratio of opposite to hypotenuse. Let's draw in the right triangle here. It doesn't have to be drawn to scale. And the reason why we don't need reference angle is because theta is in quad 1. If theta wasn't in quad 1, we would use a reference angle. So we'll just note here, theta in quad 1. Okay. So sine of theta is root 5 over 5. That means in our right triangle, the ratio of opposite to hypotenuse is root 5 to 5. If you have two lengths in a right triangle, we can use the Pythagorean theorem to find the remaining length. So let's call this A. We have A squared plus root 5 squared is equal to 5 squared. So leg squared plus leg squared is equal to hypotenuse squared. A squared plus 5 is equal to 25. So A squared is equal to 20. A comes out to be plus or minus root 20, but in a right triangle, we don't have to worry about minus because the lengths in a right triangle are always positive. So this is going to be square root of 20. Well, just circle the plus. And simplifying that, 20 is 4 times 5. So square root of 4 times 5 is 2 root 5. Okay. So the nice part about the triangle method, or the advantage we have here, is once you set up your right triangle, we can find all 6 trig functions at theta. Okay, so now we can find all 6 trig functions at theta. In fact, here I'm going to put theta in a different color to note they give you cosine at 2 theta, and we want to find these trig functions at theta. So once you find one trig function at theta, we can get all 6 trig functions at theta. I'll show us how to do that. So we have sine, cosine, tangent. Reciprocal of sine is cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Okay, if we were to use the Pythagorean identity method, there would be more work and we'd be working with fractions. We'd have to use one identity, another, so forth. Knock down the dominoes. But with the triangle method, once you have drawn your right triangle, now we know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Sometimes you have to simplify here. So far, we're good. Tangent is opposite over adjacent. So opposite over adjacent does simplify to 1/2 because root 5 divided by root 5 is 1. Okay. Okay, and then, oops. Once you have sine, cosine, tangent, we can reciprocate and rationalize to get the other 3. Okay, so the reciprocal of sine is cosecant. So 5 over root 5 When we rationalize that, we just end up with square root of 5. 5 over 2 root 5. When we rationalize that, we end up with just root 5 over 2. And then for cotan, I'll put down here, the reciprocal of 1/2 is just 2. So with our right triangle, we can find sine, cosine, tangent at theta, and from there reciprocate to get cosecant, secant, and cotangent at theta. Now in the problem, they only asked for sine, which is root 5 over 5, and tangent, which is 1/2. However, oftentimes in your homework, you will be asked to find all 6. Okay, so take a look at what we did here for a double star problem. They gave us the exact value of cosine at 2 theta. So since what was given was the trig function at 2 theta, we needed to use the double angle identity. And we chose strawberry because strawberry allows us to isolate sine of theta. Once we have sine of theta, we can use Pythagorean identity or triangle method, P or T, to find the other trig functions at theta. The most common error for these types of problems is not putting the angle in the correct quadrant, and that affects the plus or minus signs. This time, everything was positive because theta is in quadrant 1. However, when theta is not in quadrant 1, some of the trig functions will be negative. Okay. Do we have any questions here? And those that are joining in, welcome. Take a look at the solution. Let me know if you have any questions. This is a commonly missed problem on one of our upcoming quizzes. They'll be giving you trig function at either double angle or half angle, and from there you have to get all 6 trig functions at the angle, just like we did here. Given cosine of 2 theta, we're able to find sine of theta. From there, we can get all 6 trig functions at theta. Okay, let's test our understanding of this process with the next one. So the next one is also double star. The next one is really the same type of problem, but this time they give you sine at the half angle. So he said, whether they give you a trig function at the half angle or double angle, we have to use the identity to find a trig function at the angle x. And then from there, we can get any trig function at x. Okay, students. So this one, probably the most difficult part is that you're not in quad 1, so you really need to pay attention to the quadrant. Okay, so go ahead and try this one on your own. Once you start, just type in W for working, and please DM your answer for sine of x and tangent of x. Okay, see Genesis, Juan, Stephanie, Jacob, Miguel are working. Justin as well, thank you. 1, 2, 3. And then students, when you're finished, report your answer. It needs to be in exact form. So write your answer in exact form. Pay attention to the plus or minus signs. Oh, Esmeralda, I got you down too. Thank you. Genesis, Juan, Stephanie, Jacob, Miguel, Justin, and Esmeralda. Okay. I'm gonna pause the recording while you're working.
Recording stopped.
Message me in the DMs when you have a final answer. We're going to come together in about 2 minutes. If you're stuck, let me know that. So just communicate with me in the chat. Let's give it a few more minutes before we go through the solutions together.
Recording in progress.
Okay, we're going to resume the recording here. I saw quite a few correct answers, some that were very close. Okay, we'll start with Stephanie. So, Stephanie, which identity did you use to find a trig function at x?
I use the half angle identity to get cosine first.
Okay, great. So we're given sine of x over 2 is equal to negative 1/3. Using the half angle identity, sine of x over 2, we can look that up. That's square root of 1 minus cosine x over 2. And then this is plus or minus. So we have to determine if it's positive or negative. Make note that we're given x over 2 is in quadrant 4. Okay. So since x over 2 is in quadrant 4 is positive negative. We know that sine of the half angle is negative in quadrant 4. So that's why we select the negative one. Okay. Sine evaluated at an angle in quadrant 4 will be negative. So when we substitute in our half angle identity, we choose the negative. Okay. And we can see here, sine of x over 2 is negative 1/3. Okay, so Stephanie, what's the first step in isolating cosine of x?
Squaring both sides to get rid of the square root symbol.
That's right. We need to square both sides. So 1 minus cosine of x over 2 is equal to 1/9. Okay, so now let's use our algebra skills. Multiply both sides by 2. 1 minus cosine of x is equal to 2/9. Okay. Now we can subtract 1 from both sides. So this is negative cosine of x is equal to 2 over 9 minus, we'll say 9 over 9. We can rewrite 1 as 9 over 9. Okay. So negative cosine of x comes out to be negative 7 over 9. So cosine of x is positive 7 over 9. This is now when we need to check our quadrant. So x over 2 is between 7 pi over 4 and 2 pi. Okay. So let's multiply by 2. Multiply by 2, we get 7 pi over 2 to 4 pi. Okay, so let's draw in here. 7 pi over 2 is coterminal with 3 pi over 2. So 7 pi over 2 is right here. And then 4 pi is coterminal with 2 pi. So that means that our x is somewhere here. This is in quadrant 4. Okay. Let me tell us here that in this problem, it happens that x over 2 is in quad 4. X is also in quad 4. That's not always the case. And that's where I see mistakes happen. So sometimes, let's say your x over 2 is in quadrant 1, but your x value is in quadrant 2. So you have to pay attention. Are you finding the trig function at x or x over 2? If you're finding the trig function at x over 2, check the quadrant for x over 2. If you're finding the trig function at x, check the quadrant for x. Here it just so happens that x over 2 and x are in the same quadrant, but that's not always the case. And I do see a lot of mistakes from that. So x is in quadrant 4. We were able to determine that from what's given, because x over 2 is between 7 pi over 4 and 2 pi, which makes x between 7 pi over 2 to 4 pi. And 7 pi over 2 to 4 pi, that covers quadrant 4. Okay. So this one we're good because we know that cosine is positive in quadrant 4. So once we have one trig function, we can use right triangle triangle method to find any trig function. Remember that cosine gives you the ratio of adjacent to hypotenuse. So we draw in our right triangle. Let's go to Jacob. So Jacob, at this step, remember you have to use x prime, the reference angle. Okay. Okay, so we'll use x prime. And we know that the ratio of adjacent to hypotenuse is 7 to 9. Jacob, what is the remaining side, the remaining leg?
So I did 9 squared minus 7 squared, and that got me the square root of 32.
Okay, yes. So we have a squared plus 49 is equal to 81. A squared is equal to 32. A is plus or minus, but in the right triangle, all lengths are positive. So positive square root 32. And then Jacob, go ahead and simplify that.
Okay, so that simplifies down to 4 square root 2.
That's right, because 32 is 16 times 2. Square root of 16 is 4, and then square root of 2 stays. So the missing leg is 4 root 2. There we have all 3 lengths of our right triangle. So that means we can get any trig function at x prime. So we'll start. Sine of x prime is opposite over hypotenuse. Opposite over hypotenuse. But sine is in quadrant, or in quadrant 4, sine is negative. So sine of x is going to be negative 4 root 2 over 9. Okay, so we'll just note sine negative in quad 4. So we have to pay attention to the quadrants. Okay, tangent of the reference angle. Let's see here. Tangent of the reference angle is going to be opposite over adjacent. So that's 4 root 2 over 7. And then when we look at tangent, tangent is y over x. So y over x is negative in quadrant 4. So tangent is also negative in quadrant 4. We have to check the quadrant for x to determine if the trig function is positive or negative. Tangent is also negative in quad 4. Okay. So several students were able to generate the correct answer here. If we're not quite there yet, let's take a look at the steps. We use the half angle identity to solve for cosine of x. Once we get cosine of x, we can set up our right triangle to find any trig function evaluated at x. So our right triangle is actually set up where the angle is x prime. If we can get any trig function at x prime, then we just insert the appropriate plus or minus sign to get the trig function at x. X prime is the reference angle. Okay. Students, are there any questions with this last problem? So we've seen 2 problems where they give you the exact value of a trig function at either the double angle or half angle. From there, you can find the exact value of any trig function at the angle itself. And in the homework and quizzes, there will be problems where you have to simplify the square roots, reduce the fractions. So always check to make sure that your answer is in simplified form. Okay, we've wrapped up chapter 3. Let's write down the identities. Chapter 3 identities. And on your chapter 3 reference guide, these are the identities that we should take note of. So we use these 10 groups of identities to help us simplify trig expressions, find the exact value of trig functions, evaluated at angles not on the unit circle, complete proofs, and then in chapter 4, we're going to learn how to solve trig equations. So here are the 10 groups of chapter 3 identities. We have reciprocal, tan, cotan, Pythagorean, even, odd, So those were the first four. And then we had the sum and difference for cosine. We had the cofunction identities. Sum and difference for sine. Sum and difference for tangent. And then the last two that we covered in section 3.5, this section, were the double angle identities and the half angle identities. Okay, so there are the 10 identity groups we covered in chapter 3. Reciprocal, tan, cotan, Pythagorean, even, odd, sum and difference for cosine, cofunction, sum and difference for sine, sum and difference for tangent, double angle, and half angle. So I bet probably half of these we already have stored to memory. The reciprocal ones, tan, cotan, Pythagorean, even, odd, perhaps the sum and difference identities for cosine, sine, and tangent. And the double angle and half angle ones, we probably are still learning. Regardless, you want to have all the identities on one page for you to use as reference. Okay, students, before we start chapter 4, are there any questions on chapter 3? I see there's a student that joined in late. Remember, if you're missing any notes, let me know so I can share my screen. You can get screenshots of what you've missed. Okay, so students that did get the correct answer for that last one, very good. I didn't get to see all your answers in my chat. Good job. Okay, so this concludes the recording for section 3.5.